Hello everyone. Can you confirm if the audio is fine and the screen is visible to you all? I hope I'm loud and clear. So, all right. Hello everyone. My name is Hariom sir. This is TLE Eliminators, and today we are going to discuss the first four problems of um educational code forces round 192. All right. So let's get right into it. Right. Let's get started. The first problem is bigram. A bigram in a string is a pair of adjacent characters. For example, if the string is hello, hello, then it contains 8 bigrams. So basically, if the length of the string is, let's say, n, then there will be n minus 1 bigrams because you can just take every two adjacent pair of characters, right? So let's say there is he, then there is he. You can take el, so there'll be el. You can take ll, then there'll be ll, and so on and so forth. You can take bigrams. Now, monocap has cards with letters. C1 cards with the letter A, C2 cards with the letter B, and CK cards with the kth letter of the Latin alphabet. He wants to make a string from these cards using each card exactly once. The resultant or the resulting string must contain at least two equal bigrams. The order of the characters in each bigram matters. For example, the string ABA does not have two equal bigrams, of course. The number of bigrams in ABA are AB and BA. So AB is not equal to BA. So it does not have two equal bigrams. Now we have to determine whether it is possible to make the string such that the conditions are satisfied, right? So there should be two bigrams in it, right? So let's just try to understand what this problem is saying, and then we'll try to solve it, right? So this is problem A, right? So how do we solve it? So first of all, we are given a string, like, so let's say the string is of A, B, C, D, A, B, A, C, D, right? Something like this. Now this is the given string to given string. Then what is told to you is that like the order of characters in this string does not really matter. All that matters is all that matters is which character is occurring how many times, right? So A is occurring how many times? It is occurring 1, 2, and 3 times, right? Similarly, B is occurring how many times? 1, 2, 2 times. Similarly, C is occurring 1, 2 times, right? And D is occurring how many times? 1 and 2, right? So we know the frequency of each character, right? Now what is asked to you in this problem is whether if we rearrange the string S, then can we obtain two set of equal bigrams or not, right? So how can we actually form a bigram? First of all, let's try to see that, right? So if you think carefully, there can be only two types of bigrams, right? So let's say there's some character, let's say A, and it is occurring 3 times, right? And let's say there is some other character, let's say A, and another A. No, let's take two A's only, and then BB, right? Now let's say this is the entire string. So does it contain a bigram? Yes. But how? Well, you can just take the first two frequencies of A and then take the last two frequencies of A, right? In this way, what you will achieve, you will see that by taking the first two occurrences, you will get AA, and by taking the last two occurrences, you get AA. Now, since both of them are equal, so you get one bigram. So that is a bigram. Now again, if you try to make another bigram, then what you can do is take AB, like take A1 from here and this another B from here. Similarly, take this A and this B. So you'll get AB. So now this again is forming a bigram. All right. So what is the minimum condition that we need to make a bigram? Right. What is the condition that we need to make a bigram? So the thing is that if you have the frequency of any character greater than or equal to 3, then you will be able to make a bigram, right? And that is very clear, because if let's say you have 3 frequency of any character, you can just take the first two and the last two, and that will give you the same string, right? For example, if you have C, 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 right? So what you can do is you can just take these three, right? And then you will make CC, and then you will make CC using these two and then these two. Similarly, this is the first case. So when is our answer yes? Answer is yes in two cases. First case is any character frequency, if it is greater than or equal to 3, then your answer is possible. Other case is that now if this case is handled, then we know that each character has a frequency less than 3, right? So each character will be present either once or twice, or it will not be present. We do not consider that case, right? So each character is either present once or twice. Other thing could be that other character, let's say B, is present once or twice, right? So we can see that if two characters are present twice, then what we can do is then we can club together, right? So AB will be one club and then AB will be another one. So we can take A from here, B from here. Similarly, A from here, B from here, right? So the second condition is that at least two characters with frequency equals to 2, right? So this is the necessary and the sufficient condition for creating a bigram, right? So do you guys have any doubts in it? How many solve? Most of the people solve 3 or 4 problems in diff education rounds. Could only solve one and had a greedy approach for 2, which obviously failed. I think I'm not cut out for this. Actually, it is not true. The greedy approach or the greedy intuition that you got was correct. It was greedy indeed. So maybe try a little more. First one got the idea for second also, but not able to implement, if I'm thinking right. Yeah, I mean, second was not that difficult, so maybe you got misguided by some random thoughts of yours. So if you keep it simple, then it will be able, you will be able to solve it, right? So what is our algorithm? Algorithm will be, right? Let me choose a bit lighter color, right? So the algorithm will be, first of all, you will find the frequency of each character. And second of all, you'll just check if, like, so you want to check whether any character has a frequency greater than or equal to 3. So it makes sense that if you choose the character with the highest frequency, right? So if the highest character, the character with the highest frequency is greater than or equal to 3, then you're good to go, right? So you'll just check like max frequency that is greater than or equal to 3, or you'll just find the two max frequencies, right? So you just need two characters with a frequency equal to 2. So why not just take the characters with the highest frequency? So you'll take like max 1 and then you'll take max 2 and check that both of them should be greater than or equal to 2. So basically they'll be 2 because you have discarded the case of 3, right? So you can just do that. Or on the other hand, you can just check whether the max 2 is greater than or equal to 2, because max 1 is greater than max 2. So if this is greater than or equal to 2, that will definitely be greater than or equal to 2, right? So that is the entire algorithm. Well, the first step you do not need to do because you are not given a string, you're actually given the frequency of each character. So just have to check this thing, right? So let me show you the code for this one. So what I did was I took the input, and then like you can solve it in linear time as well. You can just find the first two max frequencies and that will be good. But I'm a lazy guy. I just sorted the vectors in the reverse order and then just checked, like if you sort the vectors in the reverse order, the first number will have the highest frequency, right? And so on and so forth. So you just need to check if the first number is greater than or equal to 3, then the answer will be 1. Or if first number is like greater than or equal to 2, right? You just, it's the equivalent of saying this thing. And the second max is greater than or equal to 2, then the answer will be 1. So if both of these like if any of these conditions is true, then you print yes, otherwise you print no, right? So the time complexity for my solution is order of n log n. You can optimize it to order of n, of course, because the bottleneck is just finding the max number and the second max number. All right. Okay. Start with question two. Okay. Let's go with question two. You are given an array consisting of numbers 1, 2, and 3. You have to check whether it is possible to split it into three contiguous non-empty parts such that for each part I from 1 to 3, the following conditions must be true. The number of elements greater than I is at most half of that part. So like this is a very complicated thing to understand. So let's try to understand this paragraph. So what you have to do is that you have to divide the array into three pairwise disjoint contiguous non-empty parts, so that in the left part the number of ones is at least the total number of twos and threes, right? So let's write that down so that we do not forget it, right? So this is problem 2, right? So what we are told to do is that you are given an array, you have to partition it in three parts. So one part could be this, second part could be this, and third part could be this, right? Let me call them A, B, and C. Okay. So the first condition is that in the left part, the number of ones is at least the total number of twos and threes, right? So I'll write that. So in this part, what is the condition? Ones is at least twos and threes, right? This is the first condition. Second condition is in the middle part, the total number of ones and twos is at least the number of threes, right? So I'll write that. So number of ones and twos, yeah. So the number of ones and twos is greater than or equal to 3. And the right part can be anything, but it must be non-empty. So the right part is that its size should be greater than 0. That is the entire thing that you have to do. And notice that all the elements of the array will be either 1, 2, or 3, right? So let's take this example. The example is 2 double 1 double 3 1 2 3. 2 double 1 double 3 1 2 3. All right. Yes. So how do we actually partition this array? So what do we want in the first part? So first of all, like you cannot just start building the second part before you build the first part, right? So let's just try to find the first part, right? What is the condition for finding the first part? It is that the number of ones in it must be greater than or equal to the number of twos and threes, right? So I'll just maintain a variable which will count the total number of ones that I have encountered till now, right? So let's call it 1, right? So 1 will count the total number of ones that I have seen till now, so it is initialized to 0. So is 2 a 1? No, so 1 will remain 0, right? So I'll use a pointer. So this can, so till here 1 is 0. Now you see that once you encounter a 1, your 1 value will become equal to 1, right? And what is the condition? The condition is the number of ones must be greater than or equal to twos and threes. So till this part, how many ones do I have seen? So the number of ones I have seen is 1, right? This one. And the number of twos and threes, how many of them are there? There is exactly 1, 2, right? So I'll just take this one. So is this condition satisfied, that 1 greater than or equal to 1? Yes. So this is one valid part A, right? This can be one valid part A. Is this clear? I think it's clear to you. So let's just end the part A here, and then we'll try to find the part B, right? So if we start from here, so since we have find the part A, now we need to start, or we need to reset the value of 1, right? The total number of ones that I have seen till now. So I'm starting from this part, and 1 is initialized to 0 again, right? Now, since 1 is initialized to 0, once I see this 1, I'll increment 1 by 1, right? So 1 will become equal to 1. Now the condition for the second part is that the number of ones and twos must be greater than or equal to 3, right? Once I encounter this thing, can you tell me, like, what is the number of ones and twos? So ones and twos that I have seen till now is actually 1, right? Because I have only seen a 1. And what is the number of threes that I have seen? The number of threes is actually equal to 0, right? So this condition is also satisfied, right? That the ones and twos greater than or equal to 3. So this is a valid third part, or the second part actually. So this is the part B. Now what is the condition on the third part? The third part condition is it can be anything, but the size should be greater than 0, right? So this is one valid partition. So one valid partition is you take two one together, then you take one with its like one alone, and then you take the rest of the array, right? This is one valid partition. Although they have different way of doing it, it is also valid, and ours is also valid, right? So this is like one way of like understanding how the problem actually works. Now let's make some sort of claims, right? We can make some sort of claims here, right? So what do we want in the part A? We want the total number of ones to be greater than or equal to the total number of twos and threes, right? Right. This is for part A. And for part B, the thing is that the total number of ones and twos must be greater than or equal to the number of threes, right? Now tell me one thing, that if for let's say this is an array, and for let's say this prefix, the total number of ones in this thing is actually greater than or equal to the number of twos and threes, right? So this thing is satisfied. Now is it ever optimal for us to go beyond it, right? For example, I'm saying that the number of ones that you have is, let's say that is equal to 4, and the number of twos and threes that you have it, that is, let's say, equal to 3, right? So is it ever optimal for me to expand this prefix, right? So for example, your array looks something like 2 3 1 2 1 1 3 and then 1, right? So let's say till now you have only one, only a single one, and the number of twos and threes are equal to um, they are equal to, let's say this one is also 3, not 3, wait, this should be 1. Yes, this is 3 and this is 1, right? So in this part, the total number of ones are equal to 1 and the number of twos and threes are equal to 2. So this condition is not satisfied, right? So we need to move forward. Now again we get a 2, so the number of twos and threes become equal to 3. Now again that is not satisfied. Once we move here, the total number of ones increase to 2. Still the condition is not satisfied. When we move to a 3, this condition becomes 4. So this is not satisfied. When we move to a 1, this becomes 3. So again 3 is lesser than 4, that is not satisfied. But when we move to a 1, this becomes equals to 4, and then 4 is greater than or equal to 4 is satisfied. Now let's say I have another 1 here. So is it optimal for me to include this one also in the first part? That is not optimal. Why? Because since you were able to close the deal in this by choosing this prefix of a, then why are you expanding or wasting another one? That one could have contributed to making the part B, right? Because what do we want in part B? We want that total number of ones and twos need to be maximized, right? We want this part to be maximized. And if you take a 1 here, you're just wasting another one, right? So it is not optimal to expand the given prefix once conditions, like once the number of ones becomes greater than or equal to the number of twos and threes, right? This is one thing with an asterisk mark, right? I'll come to this and I'll tell you why I have marked it with asterisk. So let's not get too complicated right now. We'll get to this, right? There's one catch here, right? So my formula is that you just keep track of total number of ones, right? And then you just like close this prefix as soon as you see that the number of ones becomes greater than or equal to the number of twos and threes, right? So this can be done in a very easy way. You can just maintain the total number of ones, twos and threes, and then you can just compare their values, right? So as soon as for the first prefix where this condition becomes true, you will just say that this is my first part right there. You will not expand beyond that, right? Is this clear? Okay. In contest, is it cause of time? I think E is not solvable unless you do it fast, right? If you're able to solve A, B, C, D in 1 hour, then you'll be able to go for E, right? That's the golden rule, right? So this is the condition for the first part. Now let's talk about the second part. In the second part, you can just do the same thing, right? Whenever you see 1 or 2, you'll just increase your counter, right? So let's say I increment like take a counter, right? So that will let me rename it. I'll just call it 1 or 2. So that is one variable. I'll initialize to 0, right? So whenever I have find the first part, I'll reset this value to 0 and then I'll start from here, right? So what will I do? I'll just, whenever I see a 1 or a 2, I'll increment this value. I'll increment this value. And as soon as this condition becomes true, that the number of ones and twos become greater than or equal to the number of threes, I'll end this part, right? So I'll end the part B. And in the end, I'll just check whether like this part B, there's just some numbers left in the part C as well, right? So if it happens that let's say you find part like this For example, let's say this was the entire array, right? And then part A was this thing, and part B was this thing with this entire thing. So even though the number of ones in this part is greater than number of twos and threes, even though the number of ones and two in this part is greater than number of threes, but there is no space left for part C, right? So in that case, answer will be no, right? Okay, so if you implement this, most of your test cases will pass, but there will be one test case that will fail. So let's get to the part. Let's try to implement our algorithm first of all, right? So we did it for this one. Let's do it for this one, right? So this is nothing but, right? So we have this array, right? So what do? We'll rewrite it. Okay. This is, where is it? Okay, I lost it. Let me copy it again. It was 3, 2, 1. What is happening? Let me reopen it. Oh, I think that we have lost that part, I guess. Okay, so let's start with this. So the thing was that, so what we wanted was that given an array, we want to partition it in three parts, such that in part A and part B and part C, the number of ones in part A was greater than or equal to 2 and 3. Similarly, for part B, we wanted the number of ones and twos to be greater than number of threes, right? And we concluded that it is optimal for us to end the part A as soon as possible and to end the part B as soon as possible, right? Let's try to run our algorithm on this one. 3, 2, 1, 3, 2, 1, 2, 1, 1, 2, 3, right? So let's try to find what is the answer for this test case. So let's see. First of all, what are we trying to do? We're trying to maintain the total number of ones that we have seen till now, right? So is this a one? No. So our one will remain zero. So we maintain a variable named as one, which will be initialized to zero. And whenever we see a one, we will increment it, right? So here it is not one, so it is still zero. Here it becomes one. So here one becomes equal to one. Now we will check the condition that the total number of ones should be greater than or equal to the total number of twos and threes. So in this case here, 1 is lesser than 2 because the total number of twos and threes are 2, right? Now we go here, the total number of twos and threes increases to, like, 1 is lesser than 3, right? Because 1, 2 and 3. Now we go here, we see that 1 becomes equal to 2. So this becomes 2 less than 3 again. Now we go here, we see that 3 less than or equal to 3. So we are able to find a prefix in which the total number of ones is greater than or equal to the total number of twos and threes. So this will form our part A, right? Now let's initialize our part B from here. The condition for part B was the total number of ones and twos should be greater than or equal to 3. So here we can see that the total number of twos are actually equal to 1 and the total number of threes are 0. So 1 is greater than 0. So this forms a part B and this will form part C. So the answer for this one should be yes, right? And the for the fifth one, answer is yes, right? So it looks like our algorithm is working pretty fine. Now let's look at this test case. 1 1 3 1 1, sorry, 1 1 3 3 and 1, 1 1 3 3 and 1. Again, what is our algorithm? We'll maintain a variable which will tell us the total number of ones that we have seen till now. So 1 is initialized to 0. We go here and we see that 1 becomes equal to 1, right? So the condition is 1 becomes greater than or equal to 0, right? Because the total number of threes are 0 here. So this will form our part A, right? Now, if you see here, our counter will initialize to 0. Now, is this a 1 or 2? This is a 1, so I increment our answer by 1, right? So in this case, what do we want? We want number of ones and number of like ones and twos should be greater than or equal to 3, right? So here we see that the number of ones and the number of twos are greater than or equal to 3. So this is again 1 greater than 0. So this will form our part B, and the rest of the thing will form our part C, right? So this will form C. So this again answer is equal to yes. Now, if you look at this test case, 1 3 3 1 1, that is pretty interesting. You'll see why. 1 3 3 1 and 1, right? So here you will see that first of all, we'll see that the total number of ones here is equal to 1, right? And that is greater than or equal to like that is greater than 0, right? So this will form our part A, right? Now, if you go from here, you will notice that I initialize my 1 counter to 0, right? And what happens at this step? The total number of ones are 0 and the number of threes are 1. So 0 less than 1, so this cannot form part A. Again, you will see 0 less than 2, so this cannot form. Here you will see 1 less than 2, and here you will see 2 less than or equal to 2. So this is one partition of B, right? This is one valid partition of B. But is the answer yes? No. Answer is no. Why? Because there is no space left for part C. The size of part C should be greater than 0. So answer for this test case according to our algorithm must be no. But the answer is yes actually. So where are we missing? There is exactly just one case that we are missing. The part that where I told you about asterisk, right? Where I told you that oh, I lost it again. No. So the part where I told you that we do not need to expand our prefix once we find that the total number of ones are greater than twos and threes. That is not actually true. There is exactly one case in which we should expand our first prefix. And what is that case? Well, if you just look at this one, 1 3 3 1 1, if you had formed this as part A, then the total number of ones here would have been 1 and the total number of threes would have been 3. So that is also working fine. And in this case, what would have happened? In this case, this would have formed part B, right? Because 1 is greater than or equal to 1, and this would have some formed part C, right? So for each range, you can just say that for A, right? For A, we can notice that like our friends are 1 and our foes are 2 and 3. Similarly, for part B, our friends are twos and threes and our foes are, wait, it's 1 and 2, right? It's 1 and 2 and our foes are 3, right? So if let's say it happens in some scenario that you're able to form a part A, right? In that case, the total number of ones are actually greater than the number of twos and threes, right? And let's say that I'm talking about this scenario, like you have 1 2 and 1 and then another you have 3, right? Now if you have the choice of ending your part A here, right? This will form part A, but can you see that you have the option of including this 3 in your part A, and that will not make the answer false. Why? because the total number of ones are equal to 2 and the total number of twos and threes are equal to just 1 in this part. So if you take another one, this will increase to 2, but 2 is greater than or equal to, that is working fine, right? So by including this, what do you achieve? Well, if you include this 3 in your part A, you are reducing the total number of 4s in the part B, right? So you're just trying to help the part B, right, without worsening the scenario in part 1, right? Does this make sense? Does this make sense? Yes. 13311, that's the exact thing that I'm trying to explain you. So what is happening is that what you're trying to do is that as soon as you see that the total number of ones are greater than twos and threes, you're ending your party. But that is not optimal. What you can just do is, let's say you have 112 and then you have a 3, then let's say it can happen that the total number of threes will overpower 1 and 2 in this part B, right? And you could have saved it by including this 3 in your part A without worsening the scenario. So our algorithm should be that find part A, right, by the same logic, right? The total number of ones should be greater than or equal to the total number of twos and threes, right? You will find that greedily, that we were doing till now, right? And once you have done that, what you can do, you can just greedily try to find like how many number of threes can you include in this part right now. So what you will do is that while the next number is equal to 3, what you will do, you will just include it. Well, notice that you want to help part B, but you also do not want the total number of threes to overpower 1, right? So you will just keep a check, like total, like you will also maintain this thing, right? The total number of ones, twos and threes you will be able to maintain, and then you will just include the number of threes as long as this condition is satisfied, right? You will keep expanding your right boundary of part A and you will end it when this condition becomes false, right? So if we try to dry run our algorithm based on our new algorithm, so dry run this test case based on our new algorithm, what will happen is I'll take 13311, right? Here I have total number of ones as 1 and the number of twos and threes are equal to 0. Oh wait, this is 1 and this is 0, right? So I see that 1 is greater than 0, right? That is fine, I can end the party, but I will not do that. I'll try to include as many threes from the next number, as many as I can, right? So what I will do is I'll make a loop, like let's say this is some pointer I, then I'll increment that pointer here, and then I'll do while I is lesser than n and a of I is equal to 3, and the condition that the total number of ones is greater than number of twos and threes, I'll take it. I'll just increment my I, right? And then I'll include it in my part A, right? So what will happen is that the total number of ones are 1 here, twos and threes are 0. So once I move to this part, my total number of twos and threes will increase to 1, right? So this will become 1. Now I see that the total number of ones is greater than or equal to 1. So this will form our boundary for part A, right? And then we will just continue from this part. This will be part B and this will be part C, right? This is the entire algorithm for solving this part, for solving B. So once I write this algorithm, I'll summarize what I have told till now from the first 10 to 15 minutes, and then we'll be able to grasp it, right? I hope it's clear, right? So let me write the algorithm for you. So our algorithm is, First of all, we will maintain the total number of ones for part A, right? And as soon as the total number of ones, let's say I'm storing that in a variable named as 1, right? So I'll store like 1 should be greater than or equal to the total number of numbers that I have seen minus the total number of ones. So that will give me total number of 2s and 3s. Well, you can just figure that out on your own, right? So as soon as this condition becomes true, I'll know that I am safe here, right? Once I do that, I'll maintain my I pointer, which will like from 0 to I. This is safe, right? The total number of ones is greater than or equal to 2s and 3s. Now I'll run this loop, like while I is lesser than n and the next numbers are equal to 3, I'll try to include them as long as this condition is satisfied, right? So our algorithm will be include as many 3s as you can, right? This will be your second part. And in the like finding part B is greedy again, right? So the main tricky part for solving this problem was thinking about this thing, like you want to include as many B and as many 3s, right? And the other part will be you'll just reset your number of ones to zeros. So 1 will be 0 and 2s will be 0 and 3s will be zeros. You'll reset it and then you can just do the greedy part, right? You can just like keep track of the total number of ones plus the total number of 2s, and once this becomes greater than or equal to 3, you will just break, right? You'll just break. And what do we want for part C? Well, part C should be non-empty. You just see whether I has become equal to n. So if this has become equal to n, then the answer is no. If I is lesser than n, then the answer is yes, right? This is pretty simple to implement, right, guys? Did you understand? I solved it using pigeonhole principle. Pigeonhole principle. How? How is pigeonhole applied here? It took me half an hour to solve B. I realized that I need to include threes in A's very late. Yeah, actually this sample was life-saving. Even I did not realize that I need to include threes in the part A. But this was like this was pretty much screaming that you need to do it. I checked for every possible range A. We can make the next B and C brute forced it. What is brute forceable? It is 2 if 5. So you fixed the total number of um oh so you fixed the total number of like the ending of part A, and then you try to find whether you can form a non-empty part C. So how did you do it? Well, part A can be found pretty easily. How did you optimize it to order of n? You did the exactly same thing but wrong test cases. Thanks, Mohit. Okay, so let's see the code for this one. I hope the algorithm is clear. Let's see the code. So I took in the input, right? Now 1 maintains the total number of ones, and so basically I'll tell you what OK is, right? So this is to like basically I'm maintaining a pointer I, right? I'll iterate on the array, and whenever I see a 1, I'll increment the counter by 1, right? And what is the condition? The condition is that ones should be greater than or equal to 2s and 3s. This is for part A, right? Well, notice that the array consists of only numbers 2, 1, 2s and 3s. So what can I write 2s and 3s as? Well, 2s and 3s are nothing but the total numbers minus 1s, right? So how can I write this as? Well, till now I have processed I indices, right? So the total number of numbers are I plus 1, and then you can just do 1, right? So the total numbers are nothing but I plus 1, and then you can just subtract 1, right? So I'll see the condition that if 1 is greater than or equal to I plus 1 minus 1, then I'll do okay XOR by 1. So basically what I'm trying to do is, if I'm able to find a valid part A, then let's say I'll maintain a bit mask. So let's not think about bit mask, right? So think like, let's say you have two places. This is for valid part A and this is for valid part B. So whenever I'm finding that a valid part A is formed, I'll mark this place as 1. And whenever I find that I have find a valid part B, then I'll mark this one as 1, right? And in the end, I want to check both of them should be true, right? So you can sort of maintain two variables or two Boolean variables and do that, right? That is also fine. What I have done is I have created a mask. So whenever part A is formed, I'll do like okay XOR equals to 1. And whenever part B is formed, I'll do okay XOR equals to 2. So in the end, I just wanted to check like if this is 1 and this is 2, right? So in the end, I want to check that both of them should be true. So in the end, okay value must be equal to 3, right? So you will just do this. Oh, not this part. So once this condition is true, you have found a valid part A. Now what do you want to do? You want to extend this range and include as many threes as you can, right? So while I is then n and v of I is less equals to 3, you'll just check this condition. If it becomes false, then you'll just break out of the loop. Otherwise, you'll keep incrementing the range, right? And after this, you can just break out of the loop. Now, after this part, this is a valid partition for A, for the first prefix. Now you can just reset your counter, and then this count variable is just counting the total number of numbers that I have seen. So again, I loop from I till n, and then count will actually like maintain the total number of numbers that I have seen. So basically, just acting as I plus 1 here, right? So whenever I see a number that is equal to 1 or 2, well, you can just write this also as like, if the number is not equal to 3, then it is 1 or 2. So you can do this as well, right? So 1 will maintain the total number of 1s and 2s. And what do you want to check? Like 1 should be greater than or equal to the number of like 1s and 2 should be greater than or equal to the number of 3s. So number of 3s are count minus 1, right? If this is true, then you make the second bit as 1. You increment your counter or the variable or the pointer, and then you break out of the loop, right? And in the end, what do you want? You just want that the okay value should be 3, and the C part, that the last part must not be empty. So if both of the conditions are true, you return yes, otherwise you return no, right? Pretty simple. um Estimated rating for problem B. I don't trust on solve counts though. I'm curious how many. Well, 11,000 people solved it. I think like it's not very difficult. It must be around 1200. I think 1200, 1100, 1200. Not very difficult. But the problem, see, that should not be solved by 6,000 people. It was not that easy. And D was, I'm not sure like how many people solved D. It was kind of difficult to arrive at the formula for D, that it is LCS. So I don't know. I cannot make any comments, right? Rating change came. No, this will be one hacking phase of 12 hours. So it will be pretty late. Jump to question 3. Okay, fine. Rating of D. I think 1700, I guess, or maybe more. All right. So let's move to problem C. Well, the time complexity for problem D will be order of n because it's just traversing over the entire array, right? Let's move to problem C. Problem C is unstable elements. We are given a sorted array of integers a1 till an. We can perform any number of operations of for the following type on this array. Mark the first element of the array as well as all the elements that are not equal to the left neighbors. Then either delete all marked elements or duplicate them, right? For example, consider the array this, right? So what you have to do is you have to mark the first element as well as all the elements which are not equal to their left one, right? So this 2 is not equal to 1, so this 2 will be marked. Again, this 4 is not equal to 2, so this 4 will be marked. Similarly, 5 is not equal to 4, so 5 will be marked, right? So if you mark all the elements, so either you delete all these elements or you duplicate them. So if you delete them, then you'll be left with 114, right? And if you duplicate them, just this one will be accompanied by another one. So this one will become two ones. So this is 2. Now this 2 will become two twos, right? This 4 will become two fours. 5 will become two fives. So that is the operation. The operation cannot be performed if the array becomes empty, of course. After each operation, every element gets unmarked. Fine. We call an array of integers B reachable if it can be obtained from array A by some number of described operations. And your task is to count the total number of reachable arrays of length k. All right. So let's first try to understand what the problem is saying, and then we'll try to look how to solve it. Right. So this is nothing but problem C. Right. So what is given to you in the problem is basically given an array. Let's say the array consists of 3 3 1 2 2 2 4 4 4 5 and 6 6. Let's say this is your array. Now the problem is that you have to mark some elements. So what elements do you mark? All the elements, well, including the first element and the element which is not equal to its left neighbor, right? So this 3 will be marked, right? 3 will be marked because it is the first element. 1 will be marked because it is not equal to 3. 2 will be marked because this is not equal to 1. Well, this 2 will not be marked. Why? Because this 2 is equal to its left neighbor 2. So this will not be marked, right? But this 2 will be marked because it is not equal to 1. Again, this 2 will not be marked. This 4 will be marked because it is not equal to 2. This 4 will not be marked because it is equal to 4. Again, this 4 will not be marked because it is equal to 4. Now this 5, it will be marked because it is not equal to 4. 6 will be marked because it is not equal to 5. 6 will be not marked because it is equal to 6. Now let me put a cross mark for those elements which will not be marked and a tick mark for those elements that will be marked. So this will be marked, this will not be marked, 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 not marked, not marked, marked, not. This will be marked, this will be marked, and this will not be marked. Right. So are you able to see some sort of pattern here? Right. Well, the pattern is that if you see this array in a condensed form, right? By condensed form I mean that why not just club these threes together, so this will form 1 3. This one is single, so this will remain 1. Club these twos together, so this will become 2. These fours together, this will become 4. This will become 5, and this will become 6. Right. Now if you notice carefully that if I look at this array and try to map each element back to the this array, then only the first occurrence of each element is marked. Right, digest this. Only the first occurrence of each element is marked. So if you see this, there are two occurrences of 3, but only the first one is marked. There is only one single element of 1, like one occurrence of 1, so it will be marked. There are three occurrences of 3, but the first occurrence is marked. There are three occurrences of 4, but only the first one is marked. There is one occurrence of 5, and that is marked. There are two occurrences of 6, and first one is marked. Right. So this entire thing, right, this marking operation is nothing but which elements do you mark? Mark all the first occurrences of each block of same elements, right? And that is pretty intuitive as well. Why? Because if you read the problem statement very carefully, then they are saying that you have to mark all the elements that are not equal to their left neighbors. So if you see all the elements which are not the first occurrence of their block, their left neighbor will be exactly same as them, right? Because let's say if you're talking about this 2, then this 2 is exactly same as this 2, so this will not be marked. This 2 is exactly same as this 2, so this will not be marked. But for this 2 we need a 2, but it is the first occurrence only, so this will definitely be marked. Right. So what we have tried to do is we are trying to mark all the first occurrences of each element of a block. Right. So either we, so after marking them we are either reducing them by 1, so not reducing them by 1, well we are deleting them, or we are duplicating them. Right. So well, let's try to look at these operations one by one. Right. So I hope this till now this is clear. It is given that error is sorted. Is it? Oh, okay. That is fine. But okay, it does not matter actually. Well, if even if you switch the positions of ones and twos and threes, it will not matter. But thanks for reminding. The array is sorted. Fine. It does not matter. Even if the array was not sorted, the problem, so the solution would have been same. Right. So let's look at the first operation. Right. The first operation is that you delete each occurrence. Right. So let's say for this array I'll transform it into a sorted one. So the array is nothing but 1 triple 2. Let's take two twos. Right. Triple 2 double 3 triple 4 5 double 6. Right. So this is your array. Now if I delete, like I'll mark these elements. Right. So this is marked, this is marked, this is marked, this is marked, and this is marked. Right. Now if I delete them, what the new array will look like is it will become 1 2 2 3 4 4. This 5 will be deleted entirely, and this will become 6. Right. So I'll create a space for 5. Right. If you notice carefully, what we have done is we have reduced the size of each block by 1. Right. Because let's say the size of this one was 2, this one was 3, this one was 2, this one was 3, 1, and then 2. And what we have done is we have reduced it to 1. So from 2 it became 1, from 3 it became 2, from 2 it became 1, and so on and so forth, right? From this 1 it became 0. So a delete operation is doing nothing but it will delete one occurrence of each block by 1, right? And what does the duplicate operation do? Well, duplicate will do the opposite thing. If you choose a 1, then it will make it, like if I choose like all the mark elements and I perform a duplicate operation, this will become 1 1 1, this will become 4 times 2, this will become 3 times 3, 4 times 4, 2 times 5, and then 3 times 6. So you can notice pretty carefully or pretty easily that the duplicate operation is increasing the size of each block by 1, right? Are these two operations clear to you? Because like this is the entire thing that you need to do or observe to solve this problem, right? I hope it's clear. I can't share links in B once I fix a part. Then for part B, you need a J such that count 1 plus 2 at count J minus count 1 plus 2 and J greater than J minus I by 2. So take a function f as well, you're not able to share the link. I'm not sure why. I'm not able to understand the approach from this text that you have written. This message is not comprehensible to me. What you can do is try to send the link once, if that works, right? So I think I lost my voice there. I think I'm audible right now. So, okay, you have an approach for C, but you do not know why it doesn't work. Maybe you can try to paste the submission link and I'll be able to see that after the PCD ends, right? So, uh, we saw two things. First of all, if we try to delete something, then the block size decreases by 1 for each block. And if we try to duplicate something, then the block of like each block will increase by 1, right? So now let's say what I will do is that I'll perform the delete operation first, right? So let's consider that. So instead of considering this array, like this given array, what I will do is like the values of each element does not really matter. What it matters is like what's the size of that block, because the size of block is doing -1 on each operation. Like it will do -1, -1, -1, -1, -1, or it will do +1, +1, +1, +1, +1, right? So the values do not really matter. What matters is the size of each block. So I'll decompose my array into something like there are 2 1s, so I'll write 2, 3 2s, so I'll write 3, right? And so again 2 3 1 4. 2, 3, 1, 4. So this is nothing but size of each block, right? So this is the size of each block. So if I convert my given array into something like this, then I have only two kind of operations. The first operation is decrement each number by 1, decrement each number by 1, or I increment each number by 1, right? So either I can make it something like 1 2 1 2 0 and 3, or I can make it to something like 3 4 3 4 2 5, right? And whenever one number reaches 0, I'll remove it, right? So the new array will be looking like 1 2 1 2 3, right? This is what is given to you. Now let's say I'm telling you that, let's say you perform like x operations of deletion. So I'm telling you that you performed x, or what we should try to see is like, I am deleting all the blocks of size lesser than x, right? So if I delete all the blocks of size lesser than x, can you tell me what will be the final array, right? So, or what will be the length of the final array, right? So first of all, there will be two scenarios, right? First of all, scenario one is if there is a block of size less than or equal to x, that will be deleted completely. That will become 0. So that element, it will become 0, right? In this case only, if you see that, if let's say I fix that like the size of the minimum block will be equal to 2, right? So if I do that, this one will reduce to 0, right? If I perform two deletion operations, what will happen is basically this will become 1, this will become 2, this will become 1, this will become like this array only. So this will become this array. So this operation will completely delete this element 1, right? So let's say if I perform x deletion operations, can you tell me what will be the total length of the array? Well, to calculate the total length, what you need is the total sum of this array, right? So what will be the total sum? Like the final sum is nothing but the total sum of array minus which elements like decreased to like, if I if I deleted all the blocks of size x, then I have totally performed x minus 1 deletion operations, right? And then what will be the total number of blocks which will survive? So basically all the blocks whose size is greater than or equal to x, I need to find them. So number of blocks of size greater than or equal to x, right? So this will be your final sum or the final total length of the array, right? I think this is clear. For example, let me take an example for this one. For example, let's say your array is let's say it is 5 3 and 7, right? And then you performed like two deletion operations, right? So you deleted elements twice. So after deleting once, this will reduce to 4 2 and 6, and after deleting twice, it will look 3 1 and 5, right? So the total length here is 3 plus 1 plus 5, so that is 9, right? So are we able to, derive this 9 from our formula? Let's see. What is the total sum of the array till now? This is nothing but 5 plus 3 plus 7. So this is 15, right? And the total number of deletion operations that you performed were 2, right? 15 minus 2 times of, what do we want to have here? Well, we want to have all the elements which are greater than or equal to 3, right? Because if I'm performing two deletion operations, then I want the size to be 2 plus 1. So I want all the elements which are greater than or equal to 3. So how many greater than or equal to 3? There are 3. So this is nothing but 15 minus 6, and that is 9. So we arrive at the same result, right? So what we can see is that if you perform x, like if you want to have all the arrays of length at least x, or you fix the minimum number that is x, then you need to perform x minus 1 operations on all the other elements. So all the other elements which are less than or equal to this value, right, which are less than or equal to this x minus 1, they will be completely deleted, and all the values which are greater than or equal to x, they will remain in the array. So what we can do now is that after performing this deletion operation, what we are getting is the final size of the array. So this is the final size of the array. Let me change color. Right. So this is the final size of the array. Now, if you, let's say the final size is, let's say, equal to, let's say this value is equal to, let's call it size, right? Now, if you perform the duplication operation, then you can notice that after the duplication operation, what will happen is that your that what happens is that your size will increase as an AP, right? So what will happen is that whenever you, like, let's say the new array is something like 4 3 3 1 and 5, right? So the total number of surviving, or the total number of remaining elements are 3, right? Since there are 3 remaining elements, if you perform one duplication operation, this will become something like 3 3, or not 3 3. Well, basically we are keeping track of the total number of, like, this is the size, right? So after, so array could be looking like something like 1 1 1 2 and 3 3 3 3 3, right? So this is the decomposed part. So whenever you perform a duplication operation, this will become 1 1 1 1. So essentially this 3 will increase to 4, so this will become 4, this will become 2, and this will become 6. So in total they have increased by total of 3, right? Plus 1 in each operation. So plus 1 here, plus 1 here, and plus 1 here, right? So if the final size of the array after performing the deletion operation is, let's say, equal to sz, then whenever you perform a duplication operation, let's say you perform it x times, then the each number will increase by x, right? Because if you perform it once, each number will increase by 1. If you perform it twice, each number will increase by twice. So if you perform it x times, the each number will increase by x times, right? So your final size will be nothing but x times, or that this is the total number of so total number of times that you performed the duplication operation, multiplied by the total number of remaining elements. And the number of remaining elements are nothing but the total number of elements whose size was greater than or equal to the fixed value. So I also took x here, so let's take it, let's say y, right? So y denotes the total number of times that you're performing this operation. So y times x, right? Where what is y? Y is number of times you performed duplication operation, right? And what is x? X is nothing but the minimum size of each array or each number, right? Brute force, bro, it is not okay. Fine, I fixed it. I have an approach for C, but I don't. Okay, fine. I took it. Create a frequency map of size. Frequency dot size is one. Increment count. Otherwise, while all frequencies are not equal, subtract the minimum frequency from every element in the frequency map. Remove frequency that becomes zero. Update remaining if remaining is equals to a increment count. Finally, return count. Um, if frequency dot size is one, then there is exactly one element in the array. While all frequencies are not equal, like how, what is your approach actually? This is the implementation that you're talking about, right? How did you get to this approach? While all frequencies are not equal, you subtract the minimum frequency from all of them. So essentially what you're doing is that for each element you're trying to decrease the frequency of each element by the minimum element, right? Okay, you have a doubt. Okay, I'll check it after PCD. Okay, Kajay. My CF handle, um, that's eyes on me. The answer can be at most blocks of different elements in the array. We can just find the block of each element and sort them and do check for each block. Yes, what I have done. So what will we do is, where is it? Right. So I hope this is clear, right? So there are only two things to see in this problem. First of all, if you fix that, I will delete all the blocks of size less than or equal to x. They will all be deleted, and all the so you will delete all the blocks of size less than x, then they will be deleted, and all the blocks of size greater than or equal to x, they will change, right? So if let's say some element has a size of 3, let's say 5, right? So some element is 5. If you perform two deletion operations, like you want to take all the blocks of size equal to 3, then you will perform two deletion operations, right? And in that case you will do 5 minus 2, so that this size will become equal to 3, right? So essentially new size of everything, like new size of each block is nothing but its original size minus x minus 1, right? Where x is the fixed length that you're talking about. And when you take the summation on this thing, right, this becomes nothing but the original, like original size is nothing but the total sum, and then x minus 1 will be counted how many times for that number of times each, like this will be counted how many times for each surviving block, that will count. So for all the blocks whose length is greater than or equal to x, that will be counted here, right? So by this way you are able to find the new size of each block, and then you can just find the total sum of well, you can just find the total final size of each array, final size of the array. Well, that is nothing but this formula: the total size of the array minus x minus 1 times the number of blocks whose size is greater than or equal to x. Right, guys? So since this is done, what will be, so, okay, fine. So we were working on this part, right? So After deletion operation, if you perform the duplication operation, what will happen is that your size will increase by y into x. So this is nothing but an AP, right? If you perform it, let's say y times, then this will be the final size. If you perform it y plus 1 times, then this will be the final size. If you perform it y plus 2 times, then this will be the final size, right? So this is just forming an AP, and it is pretty easy to see that we want to check like how many arrays will be able to reach the size of k. So we want to find how many values exist so that this value becomes equal to k, and that is pretty easy to check, right? Since this is fixed for you, this is you can find, right? Then you just need to check whether like k minus size, right, divided by x, this becomes like this is not a fractional number, so k minus size modulo x should be equal to 0, right? This is the entire thing that you need, and obviously k should be greater than size, greater than or equal to size, right? So this is the entire thing. So whenever this condition is hit, then you increment your answer by 1, otherwise you don't do anything. Is the solution clear? You can DM me on Codeforces, or you can use the Discord channel of TLE Eliminators. You will be able to find me by my real name, Hariom. Indeed, you had the find longest common subsequence of the strings of that. Okay, cool. Yeah, that's the solution for D. Did you get um did you get the solution for C? I hope it is clear. It is pretty clear. I gave some sort of examples as well. So let's look at the code. The code is pretty simple for this one. You took in the input k and then you took in the array. Then for what I'm doing is like what do we have to do? The array will be given some in this format, right? 1 1 triple 2 double 3 triple 4 5 6 6. So we do not want it. We just want like how many ones are clubbed together, how many twos are clubbed together. So we just want the size of each block, right? So I just use 2 pointers to find that. So I will be my left pointer and j will be my right pointer. So whenever j is lesser than n, and as long as the size like each element of this block is equal, I increment my j, and the size of this block will be j minus I, and then I update my I, right? So in that way, I'm able to find the total number of blocks by their sizes, right? I'll be able to do this. Now, what do I want? Answer will tell me the total number of arrays which will be able to reach the size k. Well, sum is nothing but this thing, right? Where is it? Sum is nothing but the original sum. So what is the algorithm? The algorithm is, this is too thin. Cool. Right. So the algorithm is, first of all, you create this map, right? So this map will tell you like, uh, find the number of blocks of each size, right? So we'll find for each size how many blocks exist, right? Because in the end, what do we want? We just want like, we want to convert this entire thing and condense it into something like 2 3 2 3 1 and 2. So now we just wonder like, if we delete all the blocks of size, let's say 2, then I want to process 1 2 and 2 together, right? So I do not really care about how many times they come. I care about, so actually I care about how many times they come. Well, so I just want to know like for each size how many times that block comes, right? So you do this, and then you will just like fix the minimum size of block, right? So let's say I fix that x will be the size of the minimum block. Then all the blocks of length less than or equal to x minus 1, they will be deleted. So I just want to process all the blocks whose size is from x to n, right? So this gives me some sort of idea that I should traverse in the reverse order, right? Because I want to process all the blocks of size greater than let's say some value first, right? So I'll fix the minimum, the size of the minimum block. After I do that, I just want to know how many blocks were there, how many blocks of size greater than an x existed. That's what I want. And I want the total sum of those blocks, right? Because I want to put the entire thing in this formula, right? So this is nothing but the total sum of those blocks whose size is greater than or equal to x, right? And this x minus 1 multiplied by what? This will be multiplied by the total number of surviving blocks, right? So this is just the number of blocks whose size is greater than or equal to x, and this is nothing but the sum of these blocks, right? That's pretty easy. So sum will tell you the total sum of those blocks, and tot will tell you the total number of those blocks. So if a block sizes does not exist, I do not want to process it, right? Now if, let's say, this, how will we update it? Well, like some, so first of all, how will we taught update it? Well, mp of I is storing nothing but the number of blocks of this current size, right? So I update it, and then what is the total sum? Like each number I is coming mpi number of times, right? So this is nothing but the size of the block, and this is but nothing but the frequency of that size. So the total number of that will be I times mp of I. And then it's just the simple formula, right? I just apply this formula, that sum minus I minus 1. So this is the number of deletions that I need to perform, multiplied by tot, right? So this will be the final size of the array, or the final size of my new size, right? After the deletion operation, right? And I just want to check, like, if k is greater than or equal to cur, well, what do I want? I here want that, here I have done all the deletion operations. Now I want to perform the updation operations. So if current denotes the current size of the block, so now the block can increase something like current plus y into 2, right? Current plus y into 3, right? Something like this, right? So I just need to check whether they form an AP or not, right? So what will I do? The current k should be greater than or equal to cur, and k minus cur modulo tot. So basically, tot is nothing but, well, y is nothing but tot here, because y is what? Well, if you see that size is fixed, then what do you want to add? If you perform, like, let's say you have 3 or 4 elements remaining, right? And if you do plus 1 operation on each of them, so each of them will increase by 1. So this will become 4, 2, 5, and 4, right? So how many times, like, each number increased? So if you perform one operation, each number increased by 1. So the total increment was 4. So it will become 4. So if you perform 2 operations, each of them will increase by 1 again, and then the total increment will be 8. So there will be size plus 8. So what is this value 4 and 8? 4 is nothing but the total number of remaining elements, and that is nothing but tot, right? Tot is the total number of elements greater whose block size is greater than or equal to x, right? So you do this. If it is possible, then the answer will increment by 1, and in the end you can just print your answer, right? For problem C, I think the rating will be 1400 or 1500, right? 14 or 1500. For D, I think D will be a bit high. D should be a bit higher, right? It should be 1700 or above, not 1600, I think. But that's just my opinion. Okay, so the time complexity for this one will be order of n, right? Nothing too complicated, just pointers. Okay, so let's move to the last problem, problem D, right? Problem D is two-digit strings. So this is when, if you are able to discover one thing in this problem, you will be able to solve it. Otherwise, you will be able to not solve it. You just keep on scratching your head. So the problem is you're given two strings A and B consisting only of digits. In one operation, you can choose two adjacent characters of in these two strings and replace them with their sum modulo 10. For example, if this is the string, so basically I'll show you what it is, right? So after performing such an operation, the length of the string will always decrease by one. Okay. You can perform any number of operations, even zero. You have to make these strings equal. So A should be equal to B and calculate the maximum possible length of the resulting equal strings, right? The constraints are the size of A and size of B are up to 5e3. So they are expecting a solution of, let's say, n square. Or if you're able to do it on order of n, then that's best, right? This is DP. This is, who said it is greedy? Somebody solved it with greedy. Well, maybe someone is misusing the tags. Let's see. This is DP. Yeah, this is DP. So how do we solve this? So basically try to understand what this problem is saying first of all, right? So currently we are solving problem D, right? So how do we, so basically the thing is, let's take this example only, 57246. So the string is 57246, right? So what you can do with this string is you can choose any two adjacent characters. Let me choose 7 and 2, and then what you will do is you'll just add them. So what will happen is 7 plus 2 will become equal to 9, right? So this will become 5, 9, 4, and 6. So now notice that the size of this one was 5 and size of this one is 4. So this size has decreased by 1, right? Now let me perform this operation once more. So I'll combine these two parts. So this will be 5 plus 9 equals to 14, right? Now I will not put 14 here. What I will do is I'll put 14 modulo 10. That is nothing but 4, right? So this will become 4, 4, and 6, right? Now again, if you perform the operation here, then this will become 4, and 4 plus 6 is 10, and 10 mod 10 is 0. So this will become 0. And in the end, if you perform the operation here, then this will become 4, right? Okay. So in this way, you're able to generate some sort of possible strings, right? So how do we, like, so what is the question is? The question is that you're given two strings and you can perform this addition modulo 10 operation on both of the strings. What you have to do is you have to make both of the strings equal, right? And if you make them equal, what will be the maximum size of that equal string? Is the problem statement clear? Creating and rating deformation. Yes, maybe that's true. Clear? Okay. First of all, let's look at the case where the answer will be -1, right? So let's just forget about the case that you're able to find a final string which is equivalent, which is achievable by both of them, and that its length is maximum. Let's forget about that. First of all, let's try to understand in which case the answer will be -1, right? So I want you to understand this analogy that let's say there is some string A and there is some string B, right? You perform some sort of operations here, you perform some sort of magic and you're able to obtain some string X, and you perform another magic here and then you're able to get the string X, right? Now I want you to understand is that let's say do not stop at this string X. Let's say that string A was nothing, something like 1 2 4 3 4 1 2 whatever, right? And B was, let's say, 3 4 2 1, something like this, or whatever, 9, right? I'm not actually comparing them by value, so it might not be possible that they're able to reach the same string, but the idea that I'm emphasizing is, let's say that you're able to get to the string of, let's say, type 1 2 and 3, right? Now if you do not stop at the string X, what you can do is, let's say, perform another addition modulo 10 operation. So 1 plus 2 will become 3, right? And this 3 plus 3 will become 6. So in the end, you're able to get 6. And this 6 is achievable by adding all the numbers from A. And this 6 is achievable by adding all the numbers from B, right? So my idea is that if you do not stop merging the numbers together, then in the end, when you're left with a single number, that is nothing but the summation of all the values of A modulo 10. Is this idea clear? Right. So what I'm saying is, do not stop at any operation. Just add all the numbers of A and take the modulo 10. Similarly, add all the numbers of B and do it modulo 10. Right. And the necessary condition for the string A to reach the string B is that, let's say, from A you're able to reach X, from B you're able to reach X. Then if you perform the operation on X, you'll reach some common number, right? So let's say you reach 3. But let's say from A, after adding all the digits, you reach to number, let's say, 3. But after adding all the digits of number B and doing it modulo 10, you reached 1. Now, it is never possible that you're able to reach X, a common string, right? Because A and B itself are not common, right? I hope that makes sense, right? So what I'm saying is that first of all, calculate this thing, summation I from I equals to 1 to n, do it modulo 10. Also do this thing and do it modulo 10. And I want you to think that both of them should be same, right? If they are not same, then A is not reachable from B. They will never be able to converge to a common string, right? So in that case, the answer will be -1. Let's look at the scenario. Look at here. It is 2194 and 5062. This is 2194 and 5062. Well, if you add all the numbers of A and do it modulo 10, what you will get is 2 plus 1 plus 9 plus 4 modulo 10. This is nothing but 3 plus 4 7, 7 plus 9 16. 16 modulo 10 is 6. And if you do it here, this will be 5 plus 0 plus 6 plus 2 modulo 10. This is nothing but 13 modulo 10, that is 3. Now since 6 and 3 are not equal, the answer will be -1 in this case. And you can check in other cases that their modulo 10 value must be will be same. So here it is 16 plus 1 17, 17 modulo 10 is 7, so this is 7. Now if you do modulo 10 here, this is nothing but 5 plus 1 6 plus 4 10, and 10 plus 7 17. 17 modulo 10 will be 7. If you do here 1 2 3 4 5, like the numbers are same, so the modulo value will be same again. But that is just one thing, right? So the first check that you should implement is, yes, you understood the -1 case. The first check that you should do is add all the numbers together, do it modulo 10 for both the strings. They should match. If they are not matching, the answer is -1, right? And that is the sufficient condition as well, right? Now let's proceed forward. Now I want you to think in this manner. Let's say that from string A, you got something like string A is something like 5134226, right? Now if you look at this addition modulo 10 operation, what is it actually doing? Let's say I perform uh, addition modulo 10 operation on this part, right? I perform the addition modulo 10 operation on this part, then I'll get 6, then I perform 6 and this one, and then I perform whatever I get 7 7, and then I perform in this one. So essentially what I have done is I have combined this entire subarray, right? Or substring, whatever you want to say, right? And let's say I perform addition modulo 10 operation on these two, then that will form one other subarray. And again, when I did not perform anything here, so this will remain the same. So essentially what I'm doing is that I'm uh, segmenting the given string into multiple subarrays or multiple substrings, right? So let's say I combine this part, right? I combine this part, I combine this part, and I combine this part. And from there, I am able to get, let's say, 5. And this, what will this be? 6, 7, 7 plus 10, 7 plus 3 will be 10, and that will be 0. And this will be 8, right? So you get 508. Now, let's say that this is obtainable from string A. Now from string B, let's say string B was nothing but 2 3, right? It was 6 4 and 8, right? Now if you observe carefully, how we will arrive at 508? Well, what you can do is you can combine these two parts. You can combine these two parts and take this as common. So this will combine to 5. 6 plus 4 will be 10, modulo 10 will be 0, and this will become 508, right? So what we are trying to do is that we are segmenting, like this thing only. We are segmenting the entire string into multiple substrings. And after doing that, I want that the resulting string will be same for both of the strings, A and B, right? So let's say I am able to segment it, right? So let's say I have some array, and then I combine this part, combine this part, combine this part, and so on and so forth. Let's say this is position, let's say x1, this is x2, this is x3, this is x4, and this is 0. And let's say the other part is, let's say, n, whatever, right? Now I am telling you that I have combined 0 to x1 and did it modulo 10. I have combined 0 to x2 and did it modulo 10, right? So this is what I have done for string A. For string B, similarly, I have, let's say I have from 0 to y1, from y1 till y2, from y2 till y3, from y3 to y4, and then let's say the last part, let's say its size is m, right? Now what I'm saying is that prefix sum from x1 is modulo 10 is the same value as prefix sum from y1 modulo 10, right? Because when I combine everything here and combine everything here, I want the digit that comes here, let's say it comes 3 here, then I want 3 to come here as well, right? In if that happens, then only the string will match. So I want that the prefix sum of these digits modulo 10 must match with these digits modulo 10, right? Similarly, I want that the prefix sum of x2 minus prefix sum of x1, this thing modulo 10 is exactly equal to prefix sum of y2 minus prefix sum of y1 modulo 10. All right? Does this make sense? Prefix x1 equals to prefix y1 because same digit. Yes, exactly. We want the same digit to be present here. That's why when we are adding and doing modulo 10, we want them to become same. That's exactly right. Right? You're right, Anirudh. So now we can just replicate this idea for each substring, right? Now, if I write this for each substring, I can write in general that prefix sum on xi minus prefix sum on xi minus 1, this value modulo 10 must be equal to prefix sum on yi minus prefix sum on yi minus 1, right? Now, whenever you see these kind of operations, it should come to your mind that why not combine similar things together, right? So if I send this one here and I send this one here, you can write this as prefix sum of x1 minus prefix sum of y1. This must be equivalent to prefix sum of xi minus 1 minus prefix sum of yi minus 1, right? So what this condition is saying is that when you're iterating on, let's say I fixed, like this is let's say string a and this is let's say string b, then let's say for this part of string, this is let's say x1 length, and let's say this is let's say y1 length. Then it is saying that if prefix sum from x1 minus the value from prefix sum from y1, it is matching some other prefix sums, like let's say this is matching exactly, this difference is exactly equal to x2 minus y2. Then what you can do is you can partition this entire thing into two parts. And what are those parts? Like this is x2 and this is y2. So those parts are x2, and from there like x2 plus 1 to x1. Similarly, from y2 to y2 plus 1 till y1, right? So if this condition becomes true, then you are able to match like these values with each other, right? Now, if you try to do this naively, you can also optimize this using some sort of DP. If you have seen, like this is nothing but you are given some string, let's say a b c d a, whatever, and then let's say you're given other string, let's say this is b a b c d a b a, right? So try to compare these two things, right? What you are doing in this string a and this string b is that you are trying to see, like for each prefix, you're trying to see which c I'm going to match it with, right? So let's say if you're matching this c with this c, So this is nothing acting but this is acting as x1 and this is acting as y1, right? Similarly, if you try to see here, then this x1 is acting as this c here and this y1 is acting as this c here. So this is nothing but a string matching operation. Do you see the resemblance here? Right, guys? All right. So yeah, did you understand this? Okay, cool. So if you understand this string matching part, then this is nothing but, let's say you're given some string, then you're partitioning it into some sort of subarrays, and what do you want? You want to match this, like if you see the analogy, then what this entire thing is that if this prefix combined is making, let's say, some string 3, and let's say for other one this is making another 3. So what you're trying to do is you're trying to match this 3 with this 3, right? So what will happen in the string is that some sort of characters will be, some continuous block of characters will be combined, some will remain the same, and then others will be combined. Some will remain the same and the others will combine, right? So sort of this is happening. So this operation is nothing but we want to choose for each block what is the maximum length of that block that we can take, right? So what I will try to do is define my dp. So dpij will be the same thing LCS way LCS defines, right? So dpij will be nothing but this will be the max length of common substring, common string, such that you have considered, such that you have considered 0 till I and you have considered 0 till j. This is for string A, then this is for string B. Now how can you update these equations? Well, if let's say for prefix I is equal to prefix of j, then this means that this prefix I is matching this prefix j completely, right? So these values, let's say this is 3 and this is 3. Then what do I want is, like this prefix is matching this prefix, then I want that dp of ij will be maximized with dp of I minus 1 j minus 1 plus 1. So this is nothing but that for all the prefix from 0 to I minus 1 and all the prefixes from 0 to j minus 1, I'm adding 1 to both of them because they are the same thing, right? If it matches, I'm doing this thing. Otherwise, I'll just do dp of ij with the max of dp I minus 1j or dp ij minus 1, right? Because this is just LCS. Whether like for each I, either you match it with the previous, like previous I minus 1j, or in the other string you match it with the previous I minus 1j. Hello, hello. I think I'm audible now, right? Yep, I think I'm audible. So my mic died in the between. So so I hope the idea is clear now. Let's all that's remaining is to see what how did I code this, right? So I took in both of the strings and then I created the prefix sums for each of the strings, right? So this is nothing but addition modulo 10. So I add the prefix for each part and I do it modulo 10, right? No screen. I hope my screen is visible now, right? It is visible now, right? Hello. Yes, it is visible. So I created the prefix sum for each of the strings and then I created a 2 vector that is for LCS and then I just applied the transitions as I told you. I fixed like I and J and then for like in the default case I'll not match it. So for each I and J, I'm taking maximum of I minus 1J and IJ minus 1. And if the prefix matches, I'll do it dp of ij equals to maximum of like you can do max or you can just initialize it, like just assign it. That will also work fine, right? Then dp I minus 1 j minus 1 plus 1. Because in that case, you're matching I with j. So you're just adding one more character to your subsequence, right? So in the end, you can just check whether what is the like if both of them are equal, then you can print dp of nm. Otherwise, you can print minus 1. Well, this is nothing but like the total sum of the string A modulo 10, and this is nothing but the total sum of the string B modulo 10. So if these both of the values are matching, then you will print dp and nm. Otherwise, we will print minus 1. Yes, clear? How can you reach expert? You solved 4 today. Well, 4 is good for someone who is specialist. How much time in problem C? I think I took around 30 minutes. I'm not really sure. Let me see. I took 25 minutes. Is that correct? 25 minutes, yeah. I saw D faster than problem C, so sort of. Or maybe some, yeah. So, okay. Any else, anything doubt, any doubt other than this one? Any problem that you are facing? A, B, C, D, yeah, too. D faster than C. Yes, D, once you get, well, once you grasp this idea of prefix sums, then it's pretty simple. D code, okay. So, first of all, I just created this prefix sum for both of the strings, string A and string B, right? Once I did that, this is nothing but on this prefix sum, I want to create an LCS. So longest common substring on this, on both of these strings, right? Then I create a 2D DP vector. DP of ij will tell you that what is the length of the LCS if you have considered the prefix 0 to I and the prefix 0 to j, right? Then you'll just iterate over the entire, like you'll take for each I and each j. What you will do is, this is the case where you're not matching the ith character with the jth character. So in that case, what will happen is you'll take the you'll take either the previous one, which is I minus 1j, or you'll take from the other string. So that is I j minus 1, right? So you're matching I with j minus 1 or j with I minus 1, right? So this is the first part. Other part is that if ith prefix is matching with the jth prefix of the other string, in that case, you can just like append this character to your answer, right? Sort of something like this. So it is just nothing but dpij is equal to dpi minus 1 j minus 1 plus 1. So I'm not emphasizing much on this part because this is a standard thing. If you're not aware about LCS, I recommend that you learn about it. This is pretty common, right? Um, okay, cool. I think this concludes our discussion for this PCD, right? Thanks for joining, guys, and thanks for watching. All right, study hard, reach whatever goals that you have set for yourself. I hope all of you all the best. Okay, bye bye.